I'm David Canning for the Madison area MPO, and the MPO's had a subscription to StreetLight for about the past year, and we've used it pretty extensively over that period. Next slide. So this slide here shows some of the ways in which we've used StreetLight data. So we've got about 6 use cases that we'll go over. So I'll start off by talking about how we've evaluated the accuracy of StreetLight daily volume estimates. Next, I'll talk about how we're using StreetLight data to validate and calibrate our travel demand model, which we're currently updating. Next, I'll talk briefly about how we're using StreetLight to calculate VMT, which is something which we're just starting to do. And lastly, I'll say a few words about the StreetLight segment analysis tool that Colleen Hosley from the MPO has been using recently. Then Ben will talk about the EJ analysis that he's been working on. And lastly, he'll describe the results of a bicycle origin destination analysis that Bill Holloway from the MPO has been working on. Next. So in use case number 1, we compared daily traffic counts with StreetLight daily volume estimates. Next. The importance of having accurate data for various different planning purposes is basically the point I was trying to make. What we did is compared, WISDOT counts and Madison counts with the data from StreetLight. Next. So this is a regression analysis that I ran, and along the x-axis are WISDOT traffic counts, annual average daily traffic counts from 2018, and along the y-axis are StreetLight volume estimates from 2018. And the results show that the StreetLight data is very reliable. The R-squared value of 0.983 shows a really strong correlation between the two. Also, we were impressed by the mean absolute percentage error for each of the volume categories you can see. So for streets with less than 15,000, for instance, the MAPE was about 8%, and from 15 to 30,000, 9%, and so on. So it was another good way of measuring the accuracy of the data. Next. Did the same kind of analysis with data from the city of Madison. So we took City of Madison average weekday traffic volumes from 2017 and compared them to StreetLight volumes from the same year. You got an even better R-squared value, 0.990. So that really exceeded our expectations. And again, the mean absolute percentage error numbers that you can see are also fall within the ranges. Next. Lastly, we compared short-term counts, which are 48-hour counts for the city of Madison, with StreetLight daily volumes, and we got what we expected, an R-squared value that was a bit lower because it's not really an apples-to-apples comparison, but this did give us a lot of confidence in the data for all of those count sites, and then also for streets where we don't have available accounts. Next. So use case number 2 is using StreetLight data for travel demand model calibration and validation. Next. So one of the ways in which we've used StreetLight data was to perform an external, internal EI and IE analysis in order to see the percentage of vehicles that just simply travel through Dane County without ever stopping in Dane County. Those are EE trips that start in Dane County and end in Dane County. Those are II trips. And then EI trips and IE trips, as you can see in the image below. Next. So this is important when it comes to travel demand model calibration. As I mentioned kind of at the beginning, we are in the process of updating our travel model, and we really didn't have a good data set for the results that we're getting here. And so StreetLight was able to provide that. And the results show that about 86% of trips start in Dane County and end in Dane County. Those are II trips. About 2.5% of trips are external trips, and the rest are external, internal, and internal, external trips. Those are about 5.6% and 5.86%. So very good data for our consultant who's currently working on updating our travel model in terms of calibrating it. Next. We're also able to use StreetLight Data for travel demand model validation purposes. So in this scenario, what we did was create about 100 different planning districts in Dane County and ran an origin destination analysis in order to get trip tables. And this is going to prove useful when it comes time to validating the trip tables in the travel model when we get to that point. And we'll be able to validate that against the travel survey data later this fall. Next. So use case number 3 is VMT. Next. So we're just starting to use this feature of StreetLight. Many of you have probably heard of SV 743 out of California, which places a huge emphasis on VMT. VMT is something that we think should be emphasized as well in Dane County. It's definitely needed when looking at the goals of the Dane County Climate Action Plan. And it's also needed for good sustainable land use and transportation planning, in that it's a good sustainable practice to try to steer new developments in areas with lower VMT. So on this slide, you're seeing census tracts in Dane County, and areas in red would be those tracts where the average VMT per household is higher, or the VMT per household is higher than the average for the county, and the green would be where it's lower. So it does make a lot of sense that the areas that are more central would have, the lower VMTs, and the areas in the outer area would have higher VMTs. There are a couple red tracks kind of within the green areas, but those just barely went over the 69.68 threshold. Next. Use case number 4 is a segment analysis tool that Colleen has worked on quite a bit. So before getting to that, should talk about the Vision Zero initiative in Madison. Madison is endorsing that. The policy is to eliminate fatalities and serious injuries that are results of crashes on streets and paths by 2030. So speed limit reduction is one of the principal components of that initiative. Next. So one corridor that's being investigated is the East Washington corridor. City staff wanted to see if reducing posted speeds, which are currently 35 miles per hour, would affect peak period congestion. And this map shows that the average speed for the AM peak periods are all between 21 and 26 miles per hour. That AM peak period is between the hours of 6 and 9 a.m. So this is probably not a good candidate for reducing speeds, as the speeds are already quite low, especially during the peak periods. We can also see the distribution of speeds for any link that we want. So that's also something that we're interested in seeing for corridor type analyses. There are a couple of limitations with this data set though, one being that the data isn't quite as granular as we would hope for. We can get down to the 1 hour time period, but can't get down to say the 30-minute or even 15. That might be asking a lot for this type of data, but perhaps that will be available in the future. Also, these speeds do take into effect the traffic signal delay. So that's another reason why they might be where they're at. Next. So this slide provides an overview of the congestion management process, and it's basically an approach to reducing congestion and maximizing safety and mobility. Next. So this slide shows the relative level of congestion in the Park Street corridor. It's really just an example of how we can perhaps use StreetLight data for a congestion management process. And just a couple things to note about this. You can see in the bottom the different congestion scales. So the red would be the most congested, 46 to 58% of the time it's congested. And then the green would be the least congested. So definitely most congested along the northern area of the Park Street corridor, and then not quite as congested south of that. So you can see relative congestion. StreetLight does give us things like average speed, free flow factor, and congestion, and we can calculate free flow speed from average speed and free flow factor. But it's worth noting that when it comes to these types of metrics, what's the best type to report to the general public? So really, I think one metric would be just total travel time in the corridor. Driving the entire corridor during perhaps an AM peak period or PM peak period. seeing what that is, and then comparing that to what the travel time in the corridor would be outside of the peak periods. That's something that StreetLight can provide for us, although it's not shown on the slide. So we also want to look at travel time reliability, and that requires percentile speeds in order to calculate that. So we would need the 50th percentile, 85th percentile, and 95th percentile speeds in order to calculate that. That's not something that StreetLight currently does provide, but so that's something we'll have to look to in the future when we get further along in the process. So that's the conclusion of the slides that I'm going to present. Ben will now talk about the EJ analysis he's worked on, and also some bike OD analyses that Bill Holloway has spent some time on.
Hey, David, quickly before you run, you got a question here. Actually, two questions, if you wouldn't mind answering. The first question is, during your comparison, were any volume comparisons made for shorter time periods, less than 24-hour volumes, such as 4 hours or 1 hour, for example?
We have done some comparisons for that. You know, most recently, WISDOT worked on a forecast for the County Trunk Highway AB area, along with US Highway 1218, since the new interchange is being done there. And so we did look at that. You know, the point here is that, you know, for general planning purposes, the kind of work that we do, we're most interested in daily volumes, but certainly comparisons should be done for shorter time intervals as well. And we've looked at that. I can't really provide any further examples of that at this time, but we haven't been disappointed with the data when looking at that. I do remember that it did make sense.
Sure, great. And then one more question, kind of to coattail on that is, do you see StreetLight traffic volume estimates taking the place of short-term actual counts in the future?
So the way I would answer that is the MPO doesn't take counts, but we have had discussions with City Madison transportation staff about using StreetLight estimates to reduce the frequency of counts on the lower volume streets and even the medium volume streets. And this would allow resources to be used for other counts, maybe bike counts and other types of things. So the turning movement counts have been pretty useful, and they are, you know, pretty time intensive otherwise to take. So that's been one of the benefits of the StreetLight subscription, is getting those turning movement counts. And also, as I mentioned kind of just previously, the hourly distribution data has been used to factor up hourly counts, and that's the example that I just gave with the WISDOT traffic forecast at County Trunk Highway AB and US Highway 1218.